Today's lesson, we're going to be taking a look at performing operations on functions. You've seen this before, now we're just using function notation, so it really shouldn't be anything too challenging. The first thing that you need to understand is there's different notations for these operations. So if you look at example 1, part A, sometimes you see the functions together and sometimes you see them separately. I think that second one, f of x plus g of x, is a bit more understandable, so I'm not sure why we would ever use that first notation, f plus g of x. But you do need to know both of them because some books and tests, etc., and when you get to college, you may see that notation. So you do need to know what they both are. My preference is the second one. So what it says is add the functions together. So we're going to start with f of x, and we will add g of x. You can put them in parentheses if you want to, and you absolutely have to when you're subtracting the function, so we'll see that on part C. But when you're adding, you're just combining like terms, so the parentheses don't really help us out at all. Our 7x squareds cancel, 12x does not have a like term, and 2 minus 5 is negative 3. So the composition of f plus g of x is 12x minus 3. Now we're also asked for the domain on this one, and if we look at the individual functions, they're both quadratic functions, and the domain of each of them is all real numbers. So when we add them together, our domain will still be all real numbers. Part B is asking us to evaluate the function that we just created at 2, at x equals 2. So we can either put 2 into the f function, put 2 into the g function, and add our answers together, or we can use our simplified form of the functions, the 12x minus 3 that we just got in part A. Well, I think that's going to be a little bit easier, so that's what I'm going to do. Replace x with 2, remembering what that function notation is. Notice how up here we had x, and on this one we have 2. So it's saying replace your x with 2. 12 times 2 gives us 24, minus 3 is 21. And subtracting the functions, as I mentioned, we have to use parentheses around this one. So we're going to take the f function again and subtract the g function. So on this one, we are going to distribute that subtraction sign, and then we'll add our like terms. So I like doing the add the opposite. And then when I add my like terms, this time I have negative 7x squared plus negative 7x squared is negative 14x squared. 12x still doesn't have any like terms. And 2 plus 5 gives us a 7. We were asked for domain on this one again. Again, they were both parabolas, so when you add or subtract them, the domain will remain all real numbers. Our next slide, we're going to look at multiplying and dividing functions. So here, again, we have that different notation. This is f times g of x, which means f of x times g of x. So we're going to take our f function and multiply it by our g function. Using our distributive property, or because they're both binomials, we can FOIL. 3x squared times 5x is 15x cubed. 3x squared times negative 2 is negative 6x squared. 1 times 5x is 5x. And 1 times negative 2 is negative 2. Now in this case, we don't have any like terms, so this is our function. Asking for the domain again. F of x is a parabola, domain is all real numbers. G of x is a line, domain is all real numbers, so we still have a domain of all real numbers when we multiply them. Part B is asking us to evaluate this function at 3, so I'm going to take my already multiplied function and substitute 3. You can also put 3 into the f of x function and multiply by the answer you get when you put 3 into the g of x function. And in this case, neither one really seems like it would be the easier route. You still have to do a bit of work on both of these. And because I only have to square, I think I'm actually going to do the second option, substituting 3 into the f function for x. So this right here that I wrote down is the f function evaluated at 3. And then I'm going to multiply that by the g function evaluated at 3. So again, up here in the f function, I replaced x with 3. And then in the g function, I replaced x with 3. So here I get 3 times 3 squared, or 3 times 9 is 27, plus 1 is 28. 5 times 3 is 15, minus 2 is 13. And then 28 times 13 gives us, I didn't think I'd use my calculator on this one, 364. All right, so part C is asking us to divide the functions. So we're going to take our f function, which was 3x squared plus 1, and divide it by the g function, which was 5x minus 2. Typically, when you get a function divided by a function, you will factor and cancel any common factors. However, in this case, neither our numerator or denominator factor, so this is it. We were asked for the domain on this one, and in this one we have a denominator. Remember, anytime you have a denominator, it cannot equal 0. So I'm going to set 5x minus 2 not equal to 0, adding 2 to both sides, and dividing both sides by 5. We got our domain restriction of x cannot equal 2/5. This last one is asking us to evaluate f times g at 5 plus f of 4. So we've got our f times g function, or we can substitute it into each of them. Since I did that last time, I'll use my f times g function, which was right up here this time. So substituting 5 everywhere there's an x. So that's the first part, evaluating f times g at 5. But it's also asking us to add the f function evaluated at 4. Well, the f function was 3 times x squared. So I'm going to replace that x with a 4 plus 1. All right, my calibration's off a little bit, so I can't get my page to extend. So then we just punch it all into our calculator. And what I would recommend doing is evaluating this with me, because if you aren't using your calculator correctly, you may get an order of operations error. So I get 1797. So if you did not get that answer, let me know and I can take a look at how you're punching that into your calculator.